Lesson 5.2 covers compound interest. Well, when the interest is compounded, the interest rate is applied and the principal increases. Compound interest accounts earn interest on the principal plus all previously earned interest. The number of times the account is compounded just means the number of times per year the interest is calculated and added to the account. So let's look at some terms that are often used when they're talking about the number of times compounded per year. If you see the term annually, that means it's compounded once per year. If you have money invested in a bank, once per year the bank is going to go in, calculate the interest, and add it to your account. If the account is compounded biannually or semi-annually, that means 2 times per year. Quarterly means 4 times per year. Monthly is 12 times per year. Weekly is 52 times per year. And daily, depending on the bank, is either 365 or some banks round down to 360 times per year. So let's look at an example. You invest $1,000 in a bank, which gives you 6% interest compounded quarterly. How much will you have at the end of the year? So with this first example, I want to break it down per quarter so you see what's actually happening to your money. And then we'll look at a formula that does this for us so we don't have to do this each time. So let's just begin with our interest formula. I equals P times R times T. In this example, I is the interest, and that's what I'm looking for. P was my principal, which was $1,000. R is my interest rate, which is 6%. If I divide this by 100, that gives me 0.06. T is my time in years. And I'm going to end up looking at what happens to this money over a full year. But since the interest is compounded quarterly, I need to look at each quarter at one time. So there's 4 quarters in a year. So that means there's 3 months in each quarter. So I'm going to look at what happens to this account every 3 months. So I'm going to do it 3 months at a time. So my time is going to be 3 months. And that's just for this example because I'm breaking the year down into the 4 parts. So for my example, I'm going to use time is 3 out of 12. So let's look at what happens in each quarter. So in my first quarter, which is just the first 3 months, my interest is I equals P times R times T. Well, the principal was $1,000. The rate was 0.06. And for the first 3 months, it's just 3 months out of the total 12 months in a year. So if I multiply this on my calculator, you can do 1,000 times 0.06, and you can either say times 3 divided by 12, or you can enter 3/12 as a fraction. But either way you do this, you get that the interest is $15. So now let's look at our new principal. After 3 months, the bank is going to calculate the interest and see that they owe me $15. So they're going to take that $15 and add it to my account. So my account is now going to have the original $1,000 that I invested plus the $15 in interest that they give me. So my new principal, or the amount sitting in my account, is $1,015. So now let's look at what happens the second quarter. This is the next 3 months. In the second quarter, to find my interest, I'm still going to use I equals P times R times T. The part that's changed is my principal. Instead of using the initial $1,000, my account now has $1,015. So my principal for the second quarter is $1,015. So my principal for the second quarter is $1,015. So for the second quarter, the interest that I earn, I can calculate that by 1,015 times 0.06 times 3/12. If I multiply this on my calculator, I get that the interest is $15.23. So now at the end of the second quarter, my new principal is the $1,015 that was already in my account, plus the interest that the bank is giving me, the $15.23. So at the end of the second quarter, my new principal is $1,030.23. So now for the third and the fourth quarter, for the third quarter, my interest is the principal times the rate times the time. I use the new principal of the $1,030.23. The interest rate is the 0.06, and the time, this is for another 3 months, so times 3/12. If you multiply this, you get $15.45. So at the end of the third quarter, my new principal was the $1,030.23 that I already had in my account, plus the interest of $15.45. So this told me my new principal was $1,045.68. Now for my fourth and final quarter, I'm going to find the interest by multiplying the principal times the rate times the time. The principal was the $1,045.68. The interest rate was 0.06, and the time was the final 3 months out of the year. So if I multiply this, I get $15.69. So my final principal was the $1,045.68 plus the $15.69. So my final principal is $1,061.37. Well, let's just look at what had happened if I had a simple interest account. If this was a simple interest account, at the end of 1 year, how much money would we have? Well, let's go back to the formula from the previous lesson. A equals P times 1 plus R times T. My A is the final amount, and that's what I'm asked for. My principal was the $1,000 I invested, so P is 1,000. My rate was the 6%. If I divide this by 100, that gave me the 0.06. And my time, the entire loan amount was for 1 year. I'm not breaking this down. I only did that in the previous example. I broke it down by the 4 quarters. But this time, I'm going to look at the entire year. So if I plug this into my formula, I have 1,000 times 1 plus 0.06 times 1. This one is simple enough you could simplify a lot of this by hand, but we'll go ahead and practice on the calculator. So we're going to begin with the part inside the parentheses. So I have 1 plus 0.06 times 1. And this just gives me 1.06. Now I multiply this by 1,000, and that gives me 1,060. So as we saw in the calculator, when we typed in 1 plus 0.06 times 1, that gave me 1.06. When we multiplied this by 1,000, we got 1,060. So that means if this had been a simple interest account, at the end of 1 year, we would have had $1,060. And we saw with the compound account, we ended up with $1,061.37. So by compounding the interest several times, we ended up with more money. It was just $1.37, but it was still more money. If I had invested more than $1,000, the extra interest would have added up more. Well, in the previous example, we found the final amount of an account compounded quarterly, and we did this by calculating the interest after each quarter and adjusting the principal. Well, for a 1-year period, we had to do this 4 times. What if the interest was applied more than 4 times? What if it was compounded weekly? I would have had to do that 52 times. Or if it was compounded daily, I would have had to do that 365 or 360 times, depending on how many days the problem told me to use in a year. So, and also this was just for 1 year. If I had left the money in the account for 10 years and it was still quarterly, I would have had to break each of those 10 years down into the 4 quarters. So I would have had to do that 40 times. So I just don't want to have to do that by hand. So we are going to use a formula for these. The formula for the compound interest when you're finding the final amount is A equals P times 1 plus R over N raised to the NT power, where A is the final amount of money, P is our principal, that's the amount we start with. As in the previous formulas, R is the interest rate, N is the new variable. N is the number of times compounded per year. And T is the time, and with the previous formulas, the time is always in years. So let's look at another example. Suppose I deposited $1,000 in an account compounded annually, and it earns 8% interest. How much money will you have in 5 years? So if I was doing this by hand, I would calculate the interest for 1 year, add that to the principal, and use that as my new principal. And then calculate the interest for the second year, do the same thing, and then the third year, the fourth year, and then the fifth and final year. But with this formula, I'm able to do that all at once. The formula will break it down by years, calculate the interest each time, and then give me the final amount after that 5th year. So my variables are A, P, R, N, and T. A is the final amount, and that's what I'm looking for. P is my principal, that's the $1,000 that I initially invest. R is my interest rate, that's 8%. If I divide that by 100, I get 0.08. N is the number of times compounded per year. Well, if I look back at my formula, it says compounded annually. Annually, if you look back at the table in your notes, meant once per year. And I'm doing this for 5 years, so my time is 5. One thing that I like to do before I plug these into the formula, I like to go ahead and multiply my NT. If you look, NT is your exponent. And I don't want to do my parentheses and then get to my exponent and have to worry about multiplying those then and typing it in incorrectly in my calculator. So after I list my values, I go ahead and find NT. 1 times 5 is 5, so my NT is 5. So when I plug that into my formula for NT, I'm not going to put 1 times 5. I'm just going to go ahead and plug in the 5. So I get A equals 1,000 times 1 plus 0.08 over 1 raised to the 5th power. So with this formula, I'm going to begin with what's inside the parenthesis. And this is another one I could do by hand. 0.08 divided by 1 is 0.08, and 1 plus 0.08 is just 1.08. But we'll go ahead and type it into the calculator just for practice. Once I get that value in the parenthesis, I'm going to raise it to the 5th power. And once I get that value, I'm going to multiply it by the 1,000. So let's look at this on the calculator first. So I'm going to begin with what's inside the parenthesis. So I have 1 plus 0.08 divided by 1. The reason I didn't use the fraction button this time is the numerator, the 0.08, is a decimal. And this calculator with the fraction button, it will not let you use a decimal for the numerator or the denominator. So if I hit equals, I get the 1.08 that we mentioned we would get. Now, order of operations, I do my exponent next. I need to raise this to the 5th power. Your exponent key is the y to the x power. The 1.08 is your base, so leave that in your calculator. You're going to type your exponent key, and then you're going to enter the 5 and hit equals. So 1.08 raised to the 5th power is 1.4693, and that number continues on. Now leave that in your calculator. Don't ever round until the very last step. If I leave that in my calculator, now I'm going to say times 1,000. And this gives me 1,469.328077. This is the final answer that's going to get rounded. So let's write this on our paper. So as we mentioned, the first thing we typed in was 1 plus 0.08 divided by 1, and that gave us 1.08. Then we raised that to the 5th power, and that gave us the 1.46, and that number continued on. On my paper, I just wrote a few decimal places, and this is the way I do it in the homework assignments as well. I'll write down a few decimal places and put the ... just to let you know that number continued on in your calculator. Now leave that in your calculator and multiply by the 1,000, and we got 1,469.328, and that number continued on. Well, I only need the first 3 decimal places because I look at that 8 and I know it's going to round the 2 up to a 3, so I end up with 1,469.33. So that means at the end of the 5 years, I'm going to have $1,469.33. Let's look at the next example. This example is comparing 2 different investment options. So suppose you have $15,000 to invest for 15 years. You go to 2 banks and they each have different investing options. The options are listed below. Which bank would you choose to invest your money in? So the first bank offers you 7% interest compounded annually. If you see the word compounded, you know it's not a simple interest account, so you know we're using the new formula. The A equals P times 1 plus R over N to the NT. So the A is my final amount, and that's what I'm looking for. P is my principal, and that's the $15,000 that I'm investing. R is my interest rate, and for this bank they're offering 7%. If I divide that by 100, I get 0.07. N is the number of times the interest is compounded. This account is compounded annually, so that's once per year, so N is 1. And T is my time in years. For both banks, my principal and my time are going to stay the same. I'm investing the $15,000 for 15 years, so my time is 15. And as I said before, I always like to multiply my N and my T. If I multiply the 1 times 15, that just gives me 15. So if I plug these into the formula, P is 15,000 times 1 plus R is 0.07, my N is 1, and the N times T was 15. So on my calculator, I'm going to begin with what's inside the parenthesis. I'm going to say 1 plus 0.07 divided by 1. Then I'm going to raise that to the 15th power, and then I'm going to take that decimal and multiply it by 15,000. So let's look at this on the calculator. So we're going to begin with the 1 plus 0.07 divided by 1. So 1 plus 0.07 divided by 1 equals 1.07. Now I need to raise this to the 15th power. So leave this in your calculator as the base. Press your Y to the X button, that's your exponent key, and then type in the exponent of 15 and hit equals. So this gives me 2.7590, and that decimal continues on. Leave that in your calculator. Don't ever round these until the final answer. Leave that in your calculator, and we're going to multiply by the 15,000. When I do this, this gives me 41,385.47311. This is my final answer, so this is the only number that's going to get rounded. So now let's write these steps out on paper. So again, when I begin with the parenthesis, I did 1 plus 0.07 divided by 1, and that gave me 1.07. I left that in my calculator and I raised it to the 15th power, and that gave me 2.75, and that decimal continued on. I left that decimal in my calculator and I multiplied by the 15,000, and that gave me the 41,385.4731, and that decimal continued on. Well, I only need to look at the third decimal place, that 3. That does not round the 7 up to an 8, so I end up with 41,385.47. So if I chose Bank A at the end of 15 years, I would have $41,385.47. So now let's look at Bank B. Bank B is offering me 6.8% interest compounded daily. So I see the word compounded, so I'm going to use the A equals P times 1 plus R over N raised to the NT power. My A is my final amount, and that's what I'm looking for. My P is my principal. It didn't change. I'm still investing the $15,000. This bank, the interest rate is 6.8%. If I divide that by 100, I get 0.068. This bank is compounding daily, so if you're not told otherwise, for daily use 365. If you ever need to use the 360, the problem will tell you. And time is still the 15 years. So for this one, if I multiply the N times T, 365 times 15 gives me 5,475. So now I'm going to plug these values into my formula. So I get 15,000 times 1 plus 0.068 divided by 365, and all of that is raised to the NT power, and that's why I went ahead and multiplied N times T and got 5,475. So on our calculator, we're going to start with what's inside the parenthesis and type that into your calculator. Then we're going to raise it to the 5,475th power, and then we're going to multiply that answer by 15,000. So let's look at this on our calculator. So we're going to begin with the 1 plus 0.068 divided by 365. So 1 plus 0.068 divided by 365 equals, and this is 1.00018, and that decimal continues on. Now we're going to raise that, hit your exponent key, raise that to the 5,475th power. And this gives us 2.7729, and that decimal continues on. Leave that in your calculator and multiply by the 15,000 and hit equals. And that gives us $41,593.96987, and that decimal continues on. Don't ever round into the last step. Always leave everything in your calculator. So as we mentioned, we begin by what's inside the parenthesis. If you typed in 1 plus 0.068 divided by 365, that gave you 1.00018, and that decimal continued on. Then next we raised that to the exponent. When we did that, we got 2.77, and that decimal continued on. Then we left that in our calculator and we multiplied by the 15,000, and that gave us 41,593.969, and that decimal continued on. Well, I look at the third decimal place, which is the 9. That is going to round the 6 up to a 7. So I end up with $41,593.97. So let's go back to the original problem. Which bank would we choose to invest our money in? Well, look back at your paper. If you invested in Bank A, you would end up with $41,385.47. In Bank B, you would have ended up with $41,593.97. So we end up with more money in Bank B. So the best option for the investing is Bank B. If you're investing money, you go with the bank where your end result, your final amount, is the higher value. If we were borrowing money, we would have went with the bank where the ending result, that final amount, was the lower value, because that would have meant the amount we paid back at the end. Now let's look at finding the principal. What if we wanted to know the amount of money we needed to deposit now in order to have a set amount of money at a future time? So suppose you want to invest some money now so that in 5 years you would have a down payment ready for a home. So you're wanting to put a certain amount of money in so that you would have a certain amount of money in the future. So let's look at our formula. We have A equals P times 1 plus R over N to the NT. We're basically wanting to know, what does the principal need to be in order to have a certain amount later? So we're wanting to solve for that P. If I was doing this on paper, I would plug in my final amount, plug in my R, plug in my N, and plug in my T. And then to solve for P, after I raise this parenthesis to this exponent, I would have to divide each side by that. Well, a lot of times this was a decimal that ran off my calculator screen, and I don't want to clear that out. I want to leave these values exact until I get to the final step. So let's look at how to rearrange our formula to come up with a new formula for P. So I have A equals P times 1 plus R over N to the NT. If I wanted to solve for P, I would need to divide both sides by that parenthesis, the 1 plus R over N, raised to the NT power. So if I do this, I end up with A divided by 1 plus R over N raised to the NT power equals P. So I'm just going to rewrite that on the other side. You don't have to rewrite that step. I just put P first. Well, this formula is still kind of cumbersome to enter into my calculator. So if you think back to your algebra classes, to your rules for exponents, if I take a base and its exponent and I move it across the fraction bar, I can take this base, the parenthesis 1 plus R over N, and its exponent, and I can move it to the numerator as long as I change the sign of the exponent. And that's what I'm going to do for this formula. So my formula for principal is P equals A times 1 plus R over N raised to the negative NT power. So this is the formula we're going to use when we're finding the principal. So for the compound interest formula, if you're finding the principal, if you're finding that initial amount, it's P equals A times 1 plus R over N to the negative NT power. The only difference between this formula and the last one is my P and my A have switched sides and my exponent has changed signs. All the variables remain the same. A is still your final amount, P is still your principal, R is your interest rate, N is the number of times compounded per year, and T is your time in years. So let's look at the example. If a bank pays 8.5% compounded quarterly, how much would have to be deposited now in order to have $10,000 in 10 years? This time I'm asked for the principal. I'm not asked for the final amount, I'm asked for the principal. So I'm going to start with the formula P equals A times 1 plus R over N raised to the negative NT power. So the A is my final amount. That's the $10,000 that I want to have. My P is the principal. That's what I'll need to invest, and that's what I'm being asked to find. R is my interest rate. That's 8.5%. If I divide that by 100, I get 0.085. N is the number of times compounded. Well, it's compounded quarterly. And if you remember, quarterly means 4 times per year. So my N is 4. T is the number of years, and this account is used for 10 years. So my T is 10. And as I mentioned in previous examples, I always like to find my NT. So NT is 4 times 10, which is 40. So now plug these values into your formula. You get P equals 10,000 times 1 plus, the rate was 0.085, divided by 4 because it was compounded quarterly, raised to the negative NT, so I have the negative 40. Don't forget the negative in this formula. So just like with the previous formulas, I'm going to begin with what's inside the parenthesis, then I'm going to raise that to the exponent, and then multiply by the 10,000. So let's look at this one on the calculator. So if I begin with what's in my parenthesis, I have 1 plus 0.085 divided by 4 and hit equals. And this gives me 1.02125. Now I need to raise this to the negative 40th power. So on your calculator, you're going to leave this in your calculator as the base, hit your exponent key, and then to type in a negative 40, you're going to type in the 40 first. Always do the number first, and then hit the plus minus key. Don't hit subtraction, but hit this plus minus key. That's your sign key. That changes the sign of the number. Now if you notice, my 40 became negative. If I hit that button again, my 40 would be positive. So whether that number is positive or negative, this plus minus key at the bottom changes the sign of it. So you type in the number first, it's a 40, and I need it to be negative, so I'm going to hit the plus minus key to make it negative, and then hit equals. And that gives me the 0.4312, and that decimal continues on. Now if I multiply this by 10,000, that gives me $4,312.3819, and that continues on. So as we saw in our calculator, the 1 plus 0.085 divided by 4 gave me 1.02, and that decimal continued on. When I raised that to the negative 40th power, I got 0.43, and that decimal continued on. When I multiplied that by 10,000, I got 4,312.3819, and that decimal continued on. Well, since this was my final answer and it's money, rounded to 2 decimal places. So I ended up with 4,312.38. So that means I would need to invest $4,312.38 now in order to have $10,000 in 10 years. So let's look at our next example. Suppose you have a 3-year-old son and you decide you want to buy your son a car for his 16th birthday. If you want to spend no more than $12,000 on the car, how much money do you need to invest into an account paying 4.5% interest compounded quarterly in order to have the money for your child's 16th birthday? So I'm being asked how much I need to invest now. So this is the formula: P equals A times 1 plus R over N raised to the negative NT power. The A is the final amount of money. I want to end up with $12,000, so my A is $12,000. P is the amount I'm investing now. That's my principal, and that's what I'm trying to find. R is my interest rate, so that's 4.5%. If I divide that by 100, I get 0.045. N is the number of times compounded. Well, this account is compounded quarterly, so my N is 4. T is my time. I want to have this money when my son turns 16, and he's 3 years old now. So that means it'll be 13 years before he turns 16. So I'm going to invest my money for 13 years. And then go ahead and multiply the N times T. 4 times 13 is 52. So if I plug this into my formula, I get 12,000 times 1 plus 0.045 divided by 4 raised to the negative 52 power. So in my calculator, I'm going to do what's inside the parenthesis. Then I'm going to raise it to the exponent, and then I'm going to multiply it by 12,000. So we're going to begin with 1 plus 0.045 divided by 4. And that gives me 1.01125. Leave that in your calculator and raise it to the negative 52 power. So I'm going to first hit my exponent key, the y to the x, and then I'm going to type 52, and then my plus minus key to make that negative, and hit equals. And this gives me 0.5589, and that decimal continues on. Leave that in your calculator and multiply that by the $12,000. And this gives me 6,707.1411, and that decimal continues on. So as we saw in our calculator, when we did 1 plus 0.045 divided by 4, that gave us 1.01, and that decimal continued on. Then we raised that to the negative 52 power, and that gave us 0.55, and that decimal continued on. We left that in our calculator and multiplied by 12,000, and that gave us the 6,707.1411, and that decimal continued on. Since this one is our final answer, this is the only one that we round. The 1 after the 4 will not round the 4 up to a 5, so we end up with 6,707.14. So that means I need to deposit $6,707.14 into the account now in order to have $12,000 when my son turns 16. Well, another type of compounding is continuous compounding. A continuous compound account is an account in which the interest is constantly or continually being applied to an account. With continuous interest accounts, we do use a different formula. This formula is A equals P times E raised to the RT power. So A is still the final amount. P is still my principal, that's the starting amount. R is my rate of interest, the interest rate. T is the time in years. Now if you notice, I didn't list the E. E is not a variable. E is an irrational number similar to pi. If you remember, pi was 3.1415 and it continues on. And we usually always rounded it to just 3.14. Well, e is also an irrational number. It's approximately 2.72. You're never going to use this decimal. You're going to use the E button on your calculator. So let's look at this example. You deposited $1,000 in an account compounded continuously that earns 6% interest. How much money will you have in 5 years? Well, we looked at this exact same example, but using an account compounded annually. Now let's see how much more we would earn if it was compounded continuously. So when you see the phrase compounded continuously, you're going to use the formula A equals P times e to the RT power. In this problem, A is my final amount, and that's what I'm being asked for. P is my principal, which was the $1,000. R is my interest rate, the 6%. If I divide that by 100, I get 0.06. T is my time in years, and it was 5 years. This time my exponent was RT, so I want to go ahead and multiply the R and the T before I plug this into my formula. If I multiply R times T, the 0.06 times 5 is 0.3. Now go to your formula, A equals P, which is 1,000, E, which is the button on your calculator, and your RT was the 0.3. When we enter these into our calculator, we're going to enter the exponent first. We're going to find e to the 0.3 power. Then we're going to multiply that by 1,000. On our calculator, e is associated with logarithms, and specifically the natural log. So if you've taken college algebra or a high school math class in Algebra 2, you probably used the logarithm buttons. Well, ln is your natural log, and e to the x is usually the second feature above the natural log. So to get to the e to the x, we're going to have to use our second button and then press the ln. Well, if you remember, I said e was approximately 2.72, and it's raised to the 0.3 power. So let's just enter that in first. You're never going to do this in the homework, but I just want to do this first so you'll see what number we expect to get. So if I approximate this and say 2.72 and use my regular exponent key, raise that to the 0.3 power, that gives me 1.350. So when I raise e to the 0.3 power, I expect to get a number close to the 1.35. So let's clear that out. To use the e to the x feature, you're always going to type in the exponent first. So begin with 0.3, and then we have to hit second to get to it. So second, and make sure your little second button pops up, and then press ln. And that gave me 1.3498, and that would round to the 1.35 that I got when I approximated it. So we know that we used that button correctly. Well, this is the exact value of e to the 0.3. So leave that in your calculator and multiply that by the $1,000. And this gives us 1,349.8588, and that decimal continues on. So whenever you're using the e's, always use the e button on your calculator. Don't use the 2.72. I just did that first so we would know what to expect our calculator to give us. When we raised e to the 0.3 power and multiplied it by 1,000, we got 1,349.8588, and that decimal continued on. Well, if we look at the 8 following the 5, that 8 is going to round the 5 up to a 6. So we end up with 1,349.86. So at the end of the 5 years, we'll have $1,349.86. Let's look at the next example. You deposited $5,400 in an account compounded continuously that earns 4.5% interest. How much money will you have in 10 years? Well, I saw that this was compounded continuously, so I'm going to use A equals P times e to the RT power. My A is my final amount, and that's what I'm looking for. My P is the principal, so that's the $5,400. R is my interest rate, that's 4.5%. If I divide that by 100, I get 0.045. T is the time in years, and I'm investing this for 10 years, so T is 10. Before I plug this into my formula, since my exponent is RT, I want to go ahead and multiply RT. If I multiply 0.045 times 10, I get 0.45. So now plug this into your formula. A equals P, which was 5,400, times e to the 0.45. So on our calculator, we're going to begin with the exponent. So we're going to type in the 0.45. That needs to be the exponent for my e. So I'm going to hit second and then ln to get to the e to the x power. And this gives me 1.5683, and that decimal continues on. Leave that in your calculator and multiply by 5,400. And that gives me 8,468.8858, and that decimal continues on. So we saw when we entered this into our calculator, we got 8,468.8858. If we round this to two decimal places, we get 8,468.89. So I will have $8,468.89. Now, just like in the previous examples with the compound interest, I had a formula for computing the final amount, which began with A equals. I also had a formula for computing the principal. Basically, I took the formula for the final amount and I switched the A and the P and changed the sign of the exponent. I can do the same thing with my continuous compound interest formula. If I switch the A and the P and have P equals A times E, the sign of my exponent changed. But all my values stayed the same. A is still the final amount, P is still the principal, R is still the interest rate, and T is still the time in years. And E is still my irrational number that was approximately 2.72. But remember, in this class, don't ever use the 2.72. Always use the E on your calculator. So let's look at the example. You need to have $3,500 in 5 years. How much money will you have to deposit now in an account compounded continuously, earning 4.25% interest? So this time I'm asked for the principal, so I'm going to start with the formula P equals A times e to the negative RT. My A is my final amount, and that's the $3,500 that I want to end with. My P is my principal, and that's what I'm looking for. R is my interest rate, which is 4.25%. If I divide that by 100, I get 0.0425. T is my time in years, and this was for 5 years, so my T is 5. And just like before, my exponent was RT, so I want to multiply the R and the T. 0.0425 times 5 gives me 0.2125. Now plug these into the formula, and I get P equals 3,500 times E raised to the negative 0.2125. So we're going to begin with the e raised to the negative 0.2125 power, and then we're going to multiply that by 3,500. So begin with your exponent. I have negative 0.2125. So I'm going to enter in 0.2125 and press my plus minus button to make it negative. This needs to become the exponent for the e. So hit second ln, and that gives me 0.808, and that decimal continues on. Leave that in your calculator and multiply that by 3,500. And that gives me 2,829.9611, and that decimal continues on. So as we saw when we entered this into our calculator, we ended up with 2,829.9611, and that decimal continued on. If I round this to 2 decimal places, I get 2,829.96. So I would need to deposit the $2,829.96.